Welcome to M1. Today we're going to be looking at Chapter 5, which is Forces and Friction. I'm going to start off with resolving forces. So often we'll have an object where the force, either kind of pulling or pushing that object, will act in an angle. Okay, and what we need to be able to do is to essentially resolve this or split it up into the components of this force. So what that essentially means, if you think of this kind of logically, if I've got an object here and I'm applying this force, this object is going to move to the right. Okay, depending on how heavy this object is and how much force I'm doing, as I move it, it might also have some vertical movement, okay? But most of the kind of questions we'll be dealing with will then have a horizontal movement, and that is for sure. So looking at this kind of question, you know, this F, this force here, newtons, I'll be able to split it up into a vertical and a horizontal component. And to do this, I'm kind of just thinking of trigonometry. So if this is F, and I want to think of, you know, this being my opposite, this will be my adjacent, and this one will be my hypotenuse. So if I think of the horizontal or the vertical, let's do the vertical first. The vertical component, yeah, so I'm going to get that opposite over hypotenuse. So sine theta is opposite over hypotenuse. So this vertical component is going to be h, the hypotenuse, which is f, sine theta. If I think of the horizontal component here, which is this one, this is adjacent. We know the hypotenuse, so we're going to use cos. So cos theta is adjacent over hypotenuse, isn't it? So that means my horizontal component is going to be f cos theta. Okay, and it's all about just rearranging our trigonometry. So this is f cos theta, this one is f sine theta. So this means we've got f sine theta and f cos theta. Now, the way I tend to remember this is as follows. If I'm looking at my force and I got my angle here, which is theta, so to find the one that I have the angle of will be cos, and to have the other one, which is 90 minus that angle, will be sine. So you can see here f. So if I do another one, for example, like this, then notice I got the angle in a different place. So this one here will be f cos alpha, and this one will be f sine alpha. Because what you're doing is the cos one is always with the angle you know, and the sine is with the 90 minus that angle. Okay, if you remember it like that, then you should make resolving these forces straightforward for you. So let's look at our first example with some values. I want to resolve this into its horizontal and vertical components. So its horizontal component is going to be going to the left, and its vertical component is going to be going straight down. So this is going to be 30 cos 27. Okay, because there's my force of 30, and this is my angle, 27 degrees. That means my other one is 30 sine 27. And I can work out those as numerical values. So 30 cos 27 is 26.7 newtons. And 30 sine 27 is 13.6 newtons. So this one has a horizontal force of 13.6 newtons and a vertical force of 26.7 newtons. Okay, very, very straightforward, I hope. Just remember, cos of the angle you know. So incidentally, if I looked at what this actual angle is, 90 minus 27 is 63. So if I did 30 cos 63, I would get the same answer as this. Okay, and that's how these kind of work. So here we've got a worded question, and if I've got a worded question, I always want to make a diagram. So we've got a box of mass 12 kilograms. Okay. And that will look like this. The 12 kilograms will have a weight of 12g, 12 times gravity. Now, these will always have a normal reaction, which is kind of obvious when you think logically. If it didn't have a force acting upon it upwards, then this box would go through the floor, which doesn't make sense. So its weight acting down, it will always have a normal resistance, a normal reaction, okay, which is coming from the floor on the box. Okay, so that's my initial part of this diagram. Now we have a force of 15 newtons applied at an angle of 20 degrees. Now, it probably should have said to the horizontal in this question, but anyway. And this causes the box to accelerate along the floor. So the first thing we want to do is find the acceleration of the box. And to find the acceleration of the box, I need to split this up into its vertical and horizontal components. So the horizontal one is 15 cos 20, as that is the angle we know. And then the other one, which is our vertical, is 15 sine 20. So to find the acceleration, we need to use F equals ma. And the force propelling me forward here is 15 cos 20. The mass is 12 kilograms, and the acceleration we don't know yet. So we've got 15 cos 20 divided by 12, and this is 1.17 meters per second squared. And this is the three significant figures. So there is my acceleration. Calculate the normal reaction between the box and the floor. So for this, we're going to resolve vertically. So I'm just using an R for resolve and an arrow for the direction in which I'm resolving. So on one side, if I look at what's going up, we've got R plus, and we've got this 15 sine 20. And my forces acting down is just my 12g. So my R is going to be 12g minus 15 sine 20, and this is 112 newtons to three significant figures. Okay, remembering that g is 9.8. Okay, so g equals 9.8. So in mechanics, we tend to use 9.8 as our value. It's often given to you in the exam as in a question where it'll say use g equals 9.8. I know sometimes in science and physics, they often use 9.81, which is obviously a little bit more accurate. Now I'm going to give you 4 fairly quick questions to have a go at, and then we'll look at the next bit. So, easiest way to do this type of question is essentially with a kind of triangle law from vectors. So what I'm going to do now is I've put in where roughly that resultant force will go. It's going to go somewhere between these two, and I'm going to put these three together as a triangle. Now I've got my triangle and I've got all my angles and sizes marked on it. I can use, knowing that this is going to be an alternate angle, so this 4 and this is also 4, which means that this within my triangle is 23 degrees. That'll enable me now to find my missing angle and my missing side. For the missing side, I need to use the cosine rule. So, a squared equals b squared plus c squared minus 2bc cos a. So if this a is going to be my r, then it's going to be equal to my 4 squared plus 18 squared minus 2 times 4 times 18 times cos 23. So from this I can work out what r is. And this is 14.4 newtons to 3 significant figures there. Now I can go ahead and use the sine rule or the cosine rule with my to find the final angle. So either rule, so I'm going to use the sine rule here. So sine alpha over 4 equals sine 23 over my value of r. So rearranging this, I'm going to just multiply by the 4 and I get 6.23 degrees. And theta is going to be alpha minus 4, so it's going to be 2.23 degrees there. It's alpha minus 4 because remember that this theta is not this full angle, it's just to the horizontal. So here we have it, 2.23 degrees to this horizontal there. Okay, hopefully nice and straightforward, if not the best values I've used in this question. Now, for part B, I've drawn out my vectors, or my forces ready, and to make my triangle, I just need to join these two up. So one after the other. So I can do it like that, or I could do it like that. Okay, it doesn't matter kind of which way around, but you want one arrow, okay, going on to the next arrow. That's most important. And then all that's left to do is to join the start to the end. Okay, so go from the start to the end. And that's the direction of my resultant force. Now, my 20 Newton force makes an angle of 20 degrees with the horizontal. So that's quite important. And my 16 Newton force, that made a 40 degree angle with the horizontal. So I'm just putting the angles on here at the moment in the same place they are on the actual question. Okay, so you can see there 20 degrees, and you see here the 40 degrees. Okay, that means then that because these two are parallel with each other, the horizontal lines, I can use that to find the missing angles within my question or my diagram. Now, if I think of this as a co-interior angle, it means that this angle and this total angle must total 180. So 180 minus my 20 is 160, minus my 40, so this has got to be 120 degrees here, because this angle plus this angle must equal 180. That then allows me now to use cosine rule because I've got this, the angle opposite, and I've got the other two sides. Now let's look at taking this into inclined planes. And again, let's just jump straight in with an example. So here I have an inclined plane. We've got a block of mass 8 kilograms. It's sliding down a smooth slope, which is angled at 30 degrees. So if I want to think about the forces, I've always got a reaction force, a normal reaction. And this always is at 90 degrees, so it's always perpendicular to my surface. So you can see here it's the surface and this normal reaction is perpendicular. Then coming off this is the weight, and the weight is going to act directly down. So we've got 8 kilograms, so it's 8 times gravity, 8g. Okay, and that's going to act perfectly down. And that then gives me my triangle, my right-angled triangle. From here now I can think about all the additional forces, so I can split this gravity, this weight up I should say, 8g, into what is parallel with the plane and perpendicular with the plane. Okay, so looking at what is perpendicular with the plane first, I can think that we've got an angle here which is, well, 60 degrees, and then this angle here then is 30 degrees. So this one is always going to be 90 minus the angle, and this one then is going to be the same as this angle, so 30 degrees. So we've got 8g cos 30, 8g sine 30. Of course, you could actually use this as cos 60 if you've worked that angle out if you wanted to. So this is the force acting down the plane. This is the force then which will be, balanced out with my normal reaction. Okay, later when we look at friction, these are the forces that are going to become quite important. So we've done all the forces acting on the block. We want to find the magnitude of the normal reaction. So part B, the normal reaction is going to be equal to my 8g cos 30. So that's 8 times 9.8 times cos 30, which is 67.9 newtons to 3 significant figures. And part C is find the acceleration. So this is going to be F equals ma. The force acting down is 8g sine 30. The mass is 8 and the acceleration is a. So 8 times 9.8 times sine 30 divided by 8 is just going to be 4.9. And this is meters per second squared. And that's the acceleration down the slope. So it's quite easy, quite straightforward, just putting the forces on. And in this kind of case, what we do is we are always resolving either parallel with the plane or resolving perpendicular with a plane. So what I tend to use is diagonal arrows to show this. Perpendicular in the same direction as my R, parallel in the same direction as my slope. Okay, and that's just, you know, kind of important there to let the examiner know and let anyone looking at you working know what you're doing. Now at this point I give you 3 questions to have a go yourself, and I'll pop the answers afterwards. And of course stay tuned because we'll be moving on to friction soon. Thanks for watching so far. Now finally we're going to move on to looking at friction. Okay, now the formula for friction is F equals mu R. Okay, where F is friction, mu is the coefficient of friction, and R is the normal reaction between the two surfaces. Now, since friction can vary, you know, if you've got an object like, say, your phone is on your table, it's not going to move at the moment, and as you start to apply a force to it, okay, it will eventually start moving. But initially the friction is what is stopping it moving. Now when we're doing these kind of calculations in maths, we are often looking at the max friction, okay, or what's known as its limiting value. Okay, this is the point where the force that we apply is about to overcome friction. It's going to start moving. So initially an object, you know, you put it on a rough surface, it might not slip down that surface initially because friction is going to hold it there, and then when we start to apply more and more force, it will slowly start to move as we overcome friction. But up to that point, friction can take any value. You know, if we worked out the friction the frictional force of an object, you know, to do with where it's sitting on the plane and so on, you know, it makes sense that that force isn't a fixed force, because if it was a fixed force, then that would be like saying it's moving already. Okay, so that friction varies up until a maximum point. Okay, and it's that maximum value of friction is what we're most concerned about in these problems. So let's look at an example. I've got a block of mass 8 kilograms lying on a rough horizontal surface. So quick diagram, block 8 kilograms. The coefficient of friction between the block and the surface is 0.3. So mu equals 0.3. A horizontal force of 30 newtons is applied to the block. So imagine a force of 30 newtons being applied to the block. Find the magnitude of the frictional force acting on the block and the acceleration of the block. So we've also got a normal reaction here, and of course we've got the weight of the block acting down, and in the opposite direction of my force we will get our friction. So the first thing we want to do is find that maximum value of the friction, and to do that it's mu times r. So resolving vertically, in this case r is our force acting up and 8g is our force acting down. So we've got no other components to worry about. So our maximum value of friction is going to be 0.3 times 8g, which is 23.52 newtons. Now, resolving horizontally and using F equals ma, I can see that my force is going to be 30 minus 23.52. And mass is 8 and A is obviously what we want to find. So now I can rearrange for A. So like always, I like to get a diagram. This time we've got this theta that we can't find yet. We've got a particle of mass 2 kilograms and it's sliding down this slope. So think of your normal reaction. So we've got 2g cos theta here and 2g sine theta is the one acting down the slope. So resolving first perpendicular with the slope. That would give me that r equals 2g cos theta, which means that my maximum friction is 0.25 for mu times my 2g cos theta, which is 0.5g cos theta. Now, friction is obviously going to act up the slope. So now I can resolve parallel to the slope, and I'm using F equals ma. So 2g sine theta minus my friction, which is a half g cos theta, is equal to the mass, which is 2 times the acceleration. Now, it looks like we haven't got enough information, but we do because it's about to slide down the slope. That means it's limited. Okay, so currently it means it's in equilibrium, but it's about to slide, which is why we could use the max friction, but also why acceleration is going to be 0. So that means this is 0. So we get 2g sine theta equals a half g cos theta. Divide by cos, and then 0.5g divided by 2g, the g's cancel, leave me 1/4. So we got tan theta equals 1/4. So theta is 14.03 degrees. So let's just leave it as 14 degrees to two significant figures. Okay, that means that that's the maximum value. Anything lower than that, then the friction wouldn't need to be at its maximum. Anything then just going above that then means that essentially the weight that's acting down, that force acting down the slope, will overcome my value of friction. Again, always about the diagram. So inclined at 40 degrees, particle of mass 4 kilograms. It's going to have its normal reaction there, and it's being pushed up the slope, and that's by a horizontal force. So you think you've got a horizontal force there, P newtons. Coefficient of friction is 1/7, and acceleration is 0.3. These are all things that we need. So let's think about resolving our weight first. So we got 4g cos 40, 4g sine 40. And then, of course, if we can assume that the acceleration is acting this way, as it does say it's being pushed up the slope, then it means that friction is acting down the slope. So now I've got my diagram pretty much done. All that's really left to do is that value of P, because P, again, when I resolve that, well, at first I like to think of it acting this side because I feel it makes, more sense. Then it's going to obviously have to act up the slope, and it's going to act in this direction as well with my R, opposite my R. All I've left to do is get the angle right. So this angle has got to be 40. So we've got P cos 40, which means this is P sine 40. Now I've got everything I need to be able to solve this question. So let's resolve perpendicular. So we got R is equal to P sine 40 plus 4g cos 40, where obviously P is something that we need to find. And then resolving essentially parallel to the slope, we have a P cos 40 acting up the slope, and of course this is moving, so it's F equals ma. Acting against it is 4g sine 40 and my f. And that equals the mass, which is 4, times the acceleration, which is 0.3. So remember, friction, or the max value of friction, is mu times r. Mu is 1/7, and r is this p sine 40 plus 4g cos 40. So, you know, we've got everything now we need to be able to solve this question. Sorry, just making a bit of room here. There we are. So now all I want to do is collect my two terms which have p in it, factorize out the p, and essentially resolve everything, you know. So I want to take all my numerical values here to the right. I want to get my two p's here, factorize the p, and then divide. So I'll do that in kind of one go now-ish. And we end up with p equals 45.5 newtons. Hopefully I've not made a silly mistake in my calculator there. Let me know if I do. But yeah, just a bit of rearranging. Now, like all of these questions, the diagram, you know, is what is most important. Really helps you get a sense of the question. So this is inclined at 30 degrees. We've got a box A, which is 3 kilograms. And it's going to have a normal reaction there. And obviously this is a 3g weight acting directly down. And we knew that mu is equal to 1/3. And this is connected to a second box, which is over a pulley. So this connects up and then for my pulley and straight down to my second box there. And this is 5 kilograms, this is box B, and that's going to have a 5g weight acting down. So we got tension in this kind of string here, something just to kind of be aware of. Now it's being held at rest at the moment, and of course it's going to be released. So looking at it, I can assume that this is the direction the acceleration is going to go. I'm assuming this heavier weight is going to pull it down, so this will slide up and down that way. Of course, if I've guessed wrong, what I'd end up with is a negative value here, which would then demonstrate that this 3 kilogram weight would be pulling down and accelerating down, and the 5 kilogram will be going up. But looking at it logically, that's the way I expect it to go. Let's now resolve our forces for the 3g, or the 3 kilograms. So this is 3g cos 30. We've got 3g sine 30 acting down the slope. Also acting down the slope, let's use a different color, we would have friction as well. Okay, because if we're assuming that this is accelerating this way, we've also got friction. Now I've got pretty much all my forces attached here. I can get on with solving it. So let's look at 4a first. And we're going to resolve perpendicular to the slope. So r is going to be equal to 3g cos 30. And cos 30 is root 3 over 2, so we get 3 root 3 over 2g. I'll leave it like that rather than as a decimal. I'll pop that decimal in here, but I'll leave the full value for now. I next need to think about the overall force moving, pulling this up. So let's look at B. So for B, we want to resolve this vertically, don't we? And we know that in the way we're looking at, for our F equals MA, our 5G is going to be heavier than T, so 5G minus T equals 5A. And that's all we can do initially for B. Then we can look back at for A. And we want to resolve this now parallel to the slope. So we know T is the larger value there, so T minus my 3G sine 30 minus F, which is my friction, and then multiplied by, equals MA, so that is 3A. So what I've ended up doing, I've got two equations, but before I can go any further, because at the moment I've got three unknowns, haven't I? I've got T and A, but I've also got this F. But I can work out F because we have R. Friction, or the max value of friction, is mu times R. Mu, we are told, is 1/3. And R we got here, which is our 3√3/2. Not forgetting the G there, as I almost did. And this gives me 8.49 newtons for my friction, which I can then substitute in, giving me T minus 3G sine 30 minus the 8.49 equals 3A, or T minus 23.2. Obviously I'm going to use the full value, not this rounded value. And yeah, so we've got one equation here, two equations here, two equations, two unknowns. But if I look at them, I've got a negative T here and a positive T here. So if I add these two equations, the T's will cancel, and I don't even need to worry about working them out. So equation 1 plus equation 2, that's going to give me 5G minus T plus T minus the 23.2, and that's going to be equal to the 5A plus the 3A. So here you can see you've got 5G minus 23.2 equals 8A. So simply work this number out and divide by 8, and we get 3.23 meters per second squared. This is the three significant figures. Hopefully you followed that okay. Like I said, the diagram's really important, and just separating out, you know, your A and your B and dealing with them separately. And of course, not making the mistake of thinking it's in equilibrium, you know, that T equals that 5G. You know, because this is moving once it's released, it means you need to be using F equals MA. So here seems like a difficult question, but it shouldn't be too difficult. And we want to start off by making sure we get a nice diagram. And we've got a particle, it's sliding down the slope. There's no additional forces acting on it. And we know that mu is just mu. So let's resolve our forces first. So in this direction, we've got mg cos alpha. And acting down the slope, we have mg sine alpha. So maximum value of friction, because we've got a rough slope, okay, friction is going to be acting up the slope, the opposite direction to which I am moving. So friction is going to be mu r, and if I look at r when I've resolved perpendicular to the slope, I can see that r equals mg cos alpha. So my maximum friction is mu multiplied by mg cos alpha. Now, I want to use f equals ma, and I'm going to resolve parallel to the plane here, to the slope. So it's larger value minus my friction, which is mu mg cos alpha, and that's multiplied by ma, which is what we're trying to find. So I'm just going to do a little bit of factorising just to make it kind of a bit more obvious, but let's factorise out the mg. So we get sine alpha minus mu cos alpha equals ma. And I can divide through by m. So I can see that a is equal to g sine alpha minus mu cos alpha. And now we can say, well, the acceleration of the particle is independent of mass, of its mass, because mass, or m, does not appear in the expression for acceleration. And finishing with those words written down is what you should kind of do just to tie the question together. So thank you for watching today. If you are new to my channel or you're not subscribed at the moment, please consider hitting that subscribe button now. There's going to be plenty of videos coming up over the next few weeks for these upcoming exams, and certainly into the next year when I start putting up our more statistics, more mechanics, and some further maths as well. So if any of that is of interest to you, hit that subscribe button now.